everybody, and welcome back to Beau Maths. Hope you're all having a fantastic day, and I hope you're excited to be seeing us back in the Minecraft world here. That's right, we've got another Minecraft video for you today, and it's going to be a fun one, I think. So as the video title suggests, today I built a computer stack in Minecraft, and we're going to go through that process and kind of understand a bit more about how these bad boys work.
Preliminaries and Motivation.
So for those of you who don't know what stacks are, I'd recommend going back and checking out my previous video on them, where you went in detail with them and used an interesting application to them when it came to evaluating postfix notation operation. But just as a really quick rundown, the way stacks work is that it's a way of storing data. So you can kind of put one piece of data onto the stack and you can just kind of keep adding data to store it. But the way it stores data is it kind of keeps this order where you add constantly to what's called the top of the stack, just like you would when you're stacking normal things. And the thing is when you want to access data, you can also only access the top piece of data on the stack. So I couldn't access this bottom data, for example. I would only be able to access the top. And so to get to the bottom, I'd have to access all the data above it first. So adding to the data, we called it pushing to the stack, and removing data, we called it popping from the stack. And so I thought, well, it would be kind of fun if we could come up with an implementation of these in Minecraft. Specifically, the way I wanted to implement them was by using minecarts, specifically minecarts with chests. This is for a couple reasons. Firstly, we can place items inside of chests, and the minecarts, with their ability to move on rails like this, that gives us a really nice way of kind of visualizing the data being moved around, right? So that was kind of my motivation. I wanted to create a stack using these minecarts as our data so we can actually see them moving around. And so to do that, we're going to need to, first of all, understand a couple of preliminaries when it comes to rails. So really quickly here, this right here is called a powered rail. It can be toggled on and off. And when it's in the off state, it kind of stops the minecart in its tracks. It's kind of like a brake. But when you turn it on, well, it actually accelerates the minecart and allows it to go quite fast. Right? You see it accelerated right there. Okay, the next piece of minecart machinery we're going to be using is the rail junctions. So when we apply a redstone signal to it and we change the state of that either on or off, then that changes what way the rail is going to be facing. So we see here it's going to move to the right, whereas if we flick it now, it changes the junction and it will move forward instead. So these are some nice simple ways that we can control the movement of minecarts. And indeed, there's much more when it comes to minecarts in this game, but this is all we're going to need for the stack.
The pushing mechanism.
Alright, so the first thing I thought of when it came to the stack is we're going to need a way to kind of load the minecarts onto the stack. And so in order to do that, I kind of created this little system here where it's sort of the same thing and we just tile it and we kind of move it down. So we can make this as long as we want to. And so the idea is that we can place a minecart onto one of these spots here. And this is like basically kind of one spot for storing the data. And then when we send a short redstone pulse to it, so it can't be a long one, otherwise this will still be on when it comes here and it's just going to keep on going through, right? So we want it to be short enough so that it stops at the next kind of position for the data, right? And so by shuffling that along, we can add a new piece of data in, or we can push that onto the stack. And then if I do it again, right, we've moved the data down, which enables us to have room to place another piece of data on top of the stack. And we can kind of continue this process. And so I've created a little clock here, which will allow us to just kind of see this thing in action without me having to flick the lever over and over again. So this clock is just going to kind of keep pulsing this loader every so often. So I load a piece of data on, it gets moved down, I can push a new piece of data onto the stack, gets moved down, and so on and so forth. You get the idea, right? So it's a really nice way of being able to load data onto our stack.
The popping mechanism.
But you may notice that this isn't the complete picture yet, because what happens if I want to pop data off the stack? That's another big important aspect of stacks, is the ability to retrieve data from it. And so while this allows us to load, we still need a mechanism for taking it off of the stack. And so that takes us to this next kind of phase in our development of the stack here. So if we focus on just the red line here, we see it's pretty much just this mechanism that we built over here for the loading or the pushing of data or our minecarts onto the stack. There's a couple differences. Now you may notice there's some components added to the side here, which made it difficult for us to have the redstone coming in to power these powered rails on from the side. So what I had to do is I had to move everything up, and I'm powering the powered rails from below using these redstone torches. Now the thing is, redstone torches are on by default, right? So in order to turn them off, what I had to do is send another signal to them from this redstone torch. Because remember, when you send a redstone signal into a redstone torch, that turns it off, right? So by controlling this redstone torch here, we'll be able to control whether these are on or off, which will then control whether or not these powered rails are on or off. So when we send a pulse to this, that'll turn the powered rails on, which will then allow the data to kind of move to their next spot as necessary. So that explains kind of what's going on at this bottom level. Now, the next piece is that we are going to have these orange parts. Now, what this orange part represents is for the popping. So I'll explain this lever in a second. But if we kind of follow what will happen to this minecart, it's going to go up and then it's going to turn here and it's going to leave. So that's representing the top piece of data getting popped off the stack, and then we can do whatever we want with it afterwards, right? And then after that, we're going to get data that's further down the stack. It's going to move into the position before it, right? So essentially, once one piece of data gets popped off, that leaves an empty position, right? Which then needs to get filled by the next piece of data, which is then going to kind of go in and fill that spot. And then the next piece of data is going to go fill in the previous position, and so on and so forth. So that's what these orange lines kind of do here. But one thing to keep in mind, they're always getting diverted from their previous position. Then how do we load it into the next position when we're pushing onto the stack versus when we're popping? And so that's what the top line does. And this lever is going to essentially toggle between when we're pushing onto the stack and when we're popping off of the stack. So for example, when I turn this on, what that's going to do is it's going to send a signal to these concrete blocks, which is going to power the rail below it, which, remember, that is going to switch the junction, right? So by powering the rail below it, that causes the junction to switch, which means that when the minecart moves forward, it's just going to go over it into the next position instead of moving to the previous position, like when it is when we pop the data. So right now, this is in push mode. So if we put a piece of data on and we flip the lever to toggle the minecart, we see it just goes to the next spot, and we can do that again. Right, we just see it goes into the next position. Now, if we want to pop, we just flick this lever, so now the stack is in pop mode, so we see all these junctions have changed. So now this is going to leave the stack, and the other data is going to replace its position. So if I flip that, then we see, okay, the data has replaced the previous positions, and the top data was popped from the stack. And we could do this again. So once again, top data is popped from the stack, and it got replaced by the previous one. Now, once again, we have a clock here, so we can kind of demonstrate it. And I just want to show you what it looks like when this thing kind of keeps getting popped off. So this is in pop mode, and we're just going to activate this clock. All right, and let's watch. So that gets popped off, and we replace it. That gets popped off, and we replace it. And then once again gets popped off, and if there was more, it would get replaced, right? But now our stack is empty. Now, one thing you may have noticed is that the rates of the minecarts kind of got a little bit slower. So if this stack was really big and we just attached it to this clock, based on the timing of the clock at least, maybe some things might start to get screwed up where if it gets too slow, maybe we would get minecarts starting to collide with each other, and that would be problematic. However, since we're going to be only pushing and popping one thing at a time when we move on to our next iteration, this won't end up being an issue. So for those of you who started to notice that the rates of the minecarts got a little slower, that doesn't end up being an issue in the final product. But if you were to attach it to a clock like this, you'd have to be really careful with the timings in order to make sure it's actually a consistent popping or even pushing sort of action going on. So now that we have this, there's still kind of one inconvenience with this, and that's we have levers all over the place that we need to flip in order to operate this. So what I wanted to do now is kind of put this into one nice interface. So that's what we have over here.
The interface.
So you'll notice that pretty much it's the exact same thing as over here, right? Just copy and pasted, but then there's just a little bit added onto it. So let's kind of describe the differences here. So let's look at the interface of this thing, and we see that it's got a push and a pop mode. And depending on what state this lever is, when I flick it, it cycles between these two. So if we look at what the lever is controlling, it is controlling this piece of redstone right here. And so when it's activated, that turns on this redstone, which then sends a signal down here, and it turns on this lamp, which is what we see in the display right here. And we also see that this redstone dust, when it's on, it turns off this redstone torch, right? Because it's sending a signal to it, which negates this torch. But what that does is it makes sure that this lamp is off, and also that this dust here is off. But when we flick this lever, that turns off this redstone on the top, which then allows this redstone torch to be repowered, which then turns on this light. But it does more than just change the light displays. It also sends a signal down to this top line here, which if we recall, that was what changed the junctions, right, between our pop mode and our push mode. So right now it's in push mode, and we see that the redstone line being on means that our junctions will enable our data or our minecarts just to move forward to the next position when we push data onto our stack. So that's kind of that piece. The next piece to consider is this part right here. So this is actually going to be what pulses our system or causes the data to move. So we have an observer, which if you recall, that detects block updates. If I put something in front of this, or I update the block in front of the observer, it sends out a redstone pulse. So by having a trapdoor in front of this observer, by flicking the trapdoor, that's going to send a update to the observer, and that's going to cause the minecarts to move forward. So we see that by looking at this observer. So that updates, which then causes this observer to update, which causes this one to update, and the chain kind of continues down until we get to the bottom here, which the updating of this one causes this redstone dust to turn on. And then that triggers this line here, which then turns off this torch. Now the turning off of that torch has the same function as the turning off of this one, right? Which is going to send a temporary pulse to the powered rails, which then allows our data to move, either to be pushed further down the stack or to replace the previous position if we pop off of the stack. So that's what this piece is doing here. And we have this redstone repeater here just so that we actually extend the length of the pulse, because the pulse from an observer is quite short by default, but we need it to be a little bit longer for the tracks to work properly. So by putting a repeater at the attached to it, we lengthen the pulse a little bit. And that's important because if the pulse is too short, the powered rail will turn on, but it will turn on for such a short amount of time that when it turns off again, the minecart is still on there and it breaks it, which then causes it to not be able to actually leave and move to the next spot. So this 4-tick repeater is essential in order for us to have that timing work out to actually move to the next position. Now you may also notice the line goes in two directions. It goes in this direction, which pulses the system, but it also goes in this direction here. So if we just kind of follow this line, it turns off this torch, right? When this is activated, that'll negate this torch, which will turn it off. So then this gets turned off, which then allows this torch to be turned on, which then turns this torch off right here. And by turning this torch off, that will deactivate this sticky piston. And when that gets deactivated, it's going to pull back a glass block. And the glass block it's pulling back is right here. And the reason for that is that we're going to load data onto this thing, but this is kind of like a little holding chamber for it. And we need this piston here because if we didn't have it, then it would just fall onto the data that we already have stored here. But what this is going to do is it's going to give us time to have the data move to the next position before the new data gets pushed onto the stack, right? Otherwise, they might end up colliding. So that's why we also have a little bit of a longer time here, right? We've got 2 repeaters at 4 ticks versus just our single repeater here. So there's more of a delay, which allows us to have time to pulse the stack through this line here, move everything forward, and then this piston will retract, which will cause the new data to go into this now vacant position. Okay, so that is how the pushing works. And one more aspect for the popping that we need to consider is just this water column here. So when our top piece of data, and let me put it into pop mode. When this top piece of data here gets popped, it's going to come up here, but we want to interact with our data when we pop it, right? Because maybe there's something inside this chest that we need. So what we're going to do is it's going to go into this water column, which is then going to shoot up to the top, and we'll be able to do whatever we want with our data when we're done with it. Okay, so now let's watch this thing in action, and we'll see that we can kind of just do everything from this interface here, and it's a nice and clean setup. Okay, so I'm going to put it into push mode so I can put some data onto this stack. So I load it up into the chamber, I flick the trapdoor to pulse the system, and we've got our first data in our stack. Then we can push another piece of data onto the stack, and let's flick the lever again. And we see, okay, that got moved forward, and our data fell down into the top of the stack, right? So we've pushed successfully into our stack. And we could do this maybe one more time, and then we'll start doing some popping. So push one more data on, everything gets moved forward, that fell down, and the data is in their appropriate positions. All right, and now what we're going to do is we're going to start popping. So I want to access the most recent piece of data. So I flip the trapdoor, that gets moved, it shoots up the water column, and the other data replaced the previous positions. All right, so then I can do whatever I want with this, and we can kind of pop once again. Right, and we see we just get our data coming up here, and we can do whatever we want with it. Okay, awesome. So now we officially have a working stack in Minecraft with a nice little interface to go with it. So I think this is really cool. I had a lot of fun designing this. But before we go, let's actually do a calculation using this stack.
Calculation.
We saw in the last video that if we have an expression in postfix notation, we can actually evaluate that expression using stacks. So over here, I have an expression in postfix notation. So each of the minecarts are different numbers. So we got 40, 20, divide, and then each of these banners represent the various operations that we're going to be doing. And if you don't recall this, maybe go back and check out the previous video where we looked at how to do these calculations using stacks. But essentially, whenever we have a number, we're going to push it onto the stack. And whenever we get an operation, we're going to pop twice from the stack. So that's going to get the two numbers that are going to combine with this operation. And then we take the result of that and we push it back onto the stack. And we just kind of keep on going until we're done with our inputs here and we get our result from the stack. And these three item frames here are just going to be where I actually put the kind of current calculation based on whatever operation I'm using. So let's go through this example, and we're going to basically see kind of the flow of how a computer calculates these, but we're going to use this stack that we've just created. Okay, so let's start going through this calculation, and we're just going to go from left to right, just as a computer would based on us entering the data. All right, so first off, we're going to input a 40. So that's a number, which means we just push it into the stack. So make sure we're in push mode, and let's get that bad boy in there. All right, so we've pushed into the stack, and we've got another piece of data, or another number to put into the stack, so that's a 20, so we'll push that in. Okay, so now it's been added, and our next input is division. So this is an operation, and since this is an operation, that means it's telling us to pop twice from the stack. So we're going to put our stack into pop mode, and we're going to do 2 pops. So here comes the first one. And this is our 20, that's the most recent data we put in there, and we're going to stick that right here for evaluation. And next up, we do one more pop because we need 2 numbers to evaluate with division, and we put the 40 right here. Once again, we need to make sure that the order is proper when it comes to using division or subtraction, and so we always do the most recent one to the right of the division, right? This is what we're dividing by, and so we need to just make sure that order is the same based on the order that we input them. Okay, so we have 40 divided by 20. When we evaluate that, we get 2, right? So 40 divided by 20 is 2. So we're going to take a 2 here, and that result gets pushed onto the stack. So we put it into push mode, and it goes onto our stack. Okay, awesome. So next up, we have another number that we're going to push onto the stack. That's a 4. Push that bad boy on. And then while that's happening, our next input is a plus. Okay, so that's an operation, which means we have to pop twice. So we're going to go into pop mode, do a couple of pops here to get our numbers that we're going to combine with addition. So this is a 4, and we'll pop again, and this is a 2. Okay, so we have 2 plus 4, so the computer goes, okay, that's 6. So nice simple calculation, and it takes the 6 and pushes it onto the stack. Right, so you're kind of getting the flow of things. Okay, so now we have 2 more pieces of data at 25. So we're going to just push that onto the stack here. And we'll get our next piece of data, which is the 23. So that's another number. So that's an input that we're going to be putting into our stack. Awesome. And now we've got 2 operations. So the first one is minus. So now that we have this minus here, that means it's an operation. So we're going to pop twice. So we've got 25 minus 23, which is 2. So we take the result, which is a 2, and we push that onto the stack. And next up, we're going to have multiplication. So we take the multiplication, and once again, operation. So we're doing 2 pops. So we get a 2. And we get a 6. So 6 times 2, that is 12. So we take our 12 and we push that result back onto the stack. You know it at this point. Okay, so that's loaded onto the stack and we're out of operations now. So this is, our result is on the stack. So what that means is, you know, we could keep adding operations to this, right? Maybe we decide we want to add 5 to it or do a few other things with our result in here. That's totally fine and something we're able to do with this stack. This is just kind of on top of the stack, ready for us to do whatever we want with it. But if we say we're done with our calculation, then all we have to do is just pop one last time and we're going to get our final result, which is a 12. So that whole calculation that we had here, the final result of that was 12. And we didn't really need to do much work. All we needed to do was just kind of use this stack, and we only had to evaluate single arithmetic expressions at a time where we were combining 2 numbers with divide, plus, minus, or times. That's something that's quite simple to do. We didn't have to worry about any order of operations, which was one of the advantages that we've talked about previously with postfix notation, right? So this kind of shows one way that computers can evaluate arithmetic expressions using stacks. And we did it with our very own stack that we built in Minecraft. So this was kind of a cool proof of concept.
Concluding thoughts.
Alright, well that's going to do it for me today. I hope you guys enjoyed that video. I think this was a really fun project. I mean, I always enjoy these Minecraft videos. But this was a really fun project, just kind of getting to design this stack and see how it works. You know, the cool thing about this is there may be tons of different ways to implement this, right? This is just the way I came up with it, but I'm sure there's ways you could make this more efficient, more quick, and all sorts of different ideas you could try. Maybe you want to come up with a stack that doesn't use minecarts with chess. So there's a lot of different possibilities with this, and I'd love to hear what you try out in the comments. So that's going to do it for me today, but you have a good one, you stay groovy, and good to see you again. I'll see you in that next juicy Beau Maths video.
Beau Maths.